All right, so we're going to work through some sample problems dealing with degrees and radians both in regards to our angles of rotation. So the first question here or problem says to draw an angle with the given measure in standard position. So an angle in standard position is going to have one side called the initial side on the positive x-axis, and the vertex is going to be at the origin, and then 2 pi over 3. We need to figure out where this angle is in terms of radians. So initially, you are looking at an angle of 0 radians, and then all the way around your circle is 2 pi radians, which means if you are going from here all the way to here, that is going to be half of the 2 pi, or 1 pi radians. And then this would be half of that, so pi over 2 radians. And so what we want to do is we want to think about where is 2/3 pi in relationship to these measures. Well, 2/3 falls between a half and 1. And so 2 pi radians, 2 pi over 3 radians, will be about right here. Okay, and so the angle we are looking at is from here to here being 2 pi over 3 radians. All right, so the next one is going to be negative 4/9 pi, or negative 4 pi over 9. And so the one side, the initial side, is still going to be on the positive x-axis, and we're going to rotate this around, but because it is a negative, that tells us to rotate clockwise direction, this direction. All right, so again, we want to think about where some angle measurements are. If we go from here, which again is 0 degrees, if we rotate around to here, that would be negative pi degrees. Rotating from here to here would be negative pi over 2. Well, 4/9 is less than a half, because 4.5 over 9 would be a half. So 4/9 is going to be just a little bit less than a half, and so we're looking at that angle being about right here. Again, the negative just tells you which direction to rotate. All right, so then 450 degrees, we're going to once again start with our initial side. And 450 degrees tells us we're going to have to rotate more than one time around this circle. So going from here all the way around to here would be 360 degrees. That means we have 90 more degrees to go to get to 450. Well, 90 more degrees would put us up here. So the terminal side of our angle would be located up here, and the rotation would be all the way around one time and then going an extra 90 degrees. All right, so the next question is saying to find the measures of a positive and a negative angle that are coterminal with each given angle. So coterminal angles have the same initial side and the same terminal side, and the way that you get a coterminal angle is by adding or subtracting multiples of 360 degrees. Now that is if your angle given to you is in degrees. On question 1, the angle given to us is in radians. So instead of adding or subtracting multiples of 360 degrees, we have to do the radian equivalent of 360 degrees, which means adding or subtracting multiples of 2 pi until we get the question answered. All right, so let's start out with adding 2 pi And if you add 2 pi, you have to have a common denominator, and 2 would be equivalent to 16 pi over 8. And so when you add these together, you get 19 pi over 8. That would be a positive coterminal angle to the original angle given. All right, so now if we subtract and take 3 pi over 8 and subtract 2 pi, which was our 16 pi over 8, what that gives us then is going to be negative 13 pi over 8. That gives us one positive and one negative coterminal angle. All right, so the next one is in degrees. And so if you take 720 degrees, you can add 360 to that. That would give you a positive coterminal angle. We could also subtract 360 degrees from that, and that also would give us a positive coterminal angle. There are more than one answer to these questions. All right, so now if we take that 360 degrees and subtract 360 degrees again, that gives us 0 degrees. We don't have a negative coterminal angle yet, so we have to subtract 360 again, which would give us negative 360 degrees. So we have one positive and one negative coterminal angle. Remember, we just keep adding or keep subtracting 360 degrees until you get one positive and one negative coterminal angle. All right, so the next one is once again in radians. So we're going to start out with negative 4 pi over 5, and we're going to be adding 2 pi, which in this case, for a common denominator, we need this to be in fifths. So 2 pi is 10 pi over 5. So when you add these together, you get 6 pi over 5. That is a coterminal angle. Now if you subtract 10 pi over 5, that will give us negative 14 pi over 5, and that is a negative coterminal angle. All right, so on this problem it says P is a point on the terminal side of an angle in standard position. Find the exact value of the 6 trig ratios for the reference angle theta. All right, so negative 3, 2 is going to be over here in this position somewhere. And what we want to do is make a right triangle out of this, drawing a segment straight down to your x-axis. You always want to draw to the x-axis. All right, the reference angle theta is right here. This side is negative 3, and yes, we do need to keep the negative on this. This side is 2. Doing Pythagorean theorem will give you square root of 13 for this side. Once you have the 3 sides of your right triangle, now it's just a matter of writing your 6 trig ratios, starting with the sine of theta being the opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. All right, so now we want to look at the reciprocal trig identity. So secant is the reciprocal of cosine, which would make this square root of 13 over negative 3. Cosecant is the reciprocal of sine, so that's square root of 13 over 2. Cotangent is the reciprocal of tangent, which is negative 3 over 2. So those are your 6 trig functions here. All right, so we're going to do the same thing with this next problem. What I want you to do is go ahead and pause the video, work this one out, and then unpause the video and you can see or compare your answers. All right, welcome back, and you can compare your answers that we have here. The coordinate was 4, negative 2, so the x value is 4 and the y value is negative 2. Doing Pythagorean theorem, you're going to get square root of 20 for the hypotenuse. So they're giving you sine, which is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and then the reciprocal values over here. All right, so the last set of problems here say to determine the exact coordinates of point P. All right, so coordinates are written in terms of x, comma, y. And so if I draw a right triangle straight down, this length right here will be the x coordinate, and this length right here will be the y coordinate. Now, we can use trig functions to find these values. In particular, if this was not just a 60-degree angle, but if this was a 28-degree angle or something like that, we could just use our trig functions saying sine of this angle equals y over 10 and cosine of this angle equals x over 10, and we can get the coordinates that way. Or if we use our 30-60 triangle rules from geometry, and if you remember your 30-60 triangle rules, they look like this. When you have a right triangle with a 30-degree and 60-degree acute angles, whatever the short leg is, the hypotenuse is twice that, and the long leg is the square root of 3 times the length of the short leg. And so in this situation, the hypotenuse is 10, which means x would have to be half of that length, and then y would be the square root of 3 times this. All right, so half of 10 means that our x value is going to be 5, and the y value is going to be 5 square root of 3. Since we are in the first quadrant, both the x value and the y value are going to be positive, and that is the exact coordinates. All right, so for the next problem, we draw our right triangle going straight down or straight up to the x-axis. Well, on this one, 225 degrees from here all the way around to here. From here to here is 180, which means this little reference angle here is going to be 45 degrees, which also means this angle is 45 degrees. Now, your properties from geometry say that when you have 45 right triangle, the two legs are going to be the same length, and the hypotenuse is whatever one of those legs is times the square root of 2. All right, so in this situation, our hypotenuse is 8 root 2, which makes x 8. And therefore the coordinate, since we are in the third quadrant, both the x and the y values have to be 8. All right, so that means our coordinate for this point is going to be -8, -8.